Hi and welcome to the next in our series of lessons talking about surds. Today we're going to be looking at dividing surds. In particular, we're going to be looking at dividing a surd by another surd. So here we have root 72 divided by 2, and if you remember, once again, we have this rule that tells us the square root of a times the square root of b gives us the square root of a times b. Or, in reverse, if we take the square root of a product of two things, then we can split them back up into the two separate surds. So we take this feature and apply it to 72, we could turn root 72 into the square root of 36 times 2. If we separate that into its two individual surds, we then have the square root of 36 times root 2, all divided by root 2, and hopefully you can see that because it has a common denominator and numerator, these cancel out, which then leaves us with the square root of 36, which in turn gives us the integer answer of 6. So if we look at another one, the square root of 48, and 48 has factors, lots of them, but we do have one which includes a root 6. We know that root 48, using this splitting up, allows us to turn that into root 8 times root 6, which then in turn becomes root 8 times root 6 divided by root 6. The root 6 once again cancel, and then what we've got is the square root of 8 is equal to the square root of 4 times root 2, and it simplifies to give us 2 root 2. Right, so now that we've learned how we can use the factorising of the surds to help us to simplify when we're dividing one surd by another surd, we want to try these ones for ourselves. So stop the movie and try these. Okay, question number 1 has root 24 and root 2. So we split root 24 up, we end up getting root 12 and root 2. When the root 2's cancel, we end up with root 12, but this then will simplify even further using the rules of simplification we learned in lesson 4 to give us 2 root 3. Root 46, it splits up to root 2 times root 23. Now it's all divided by root 2. The root 2's cancel, and we end up with a surd root 23. Now this is a prime number, it doesn't have any factors, so it won't be able to simplify. The next one, root 20 splits up to root 5 times root 4. The root 5's cancel, we're left with root 4, which is a prime number, is a square number, so that'll give us the answer 2. Question number 4, we take root 24, we can split it up into root 8 times root 3. If we cancel the root 8's, we're left with root 3. It can't simplify. And this one here, root 8 times root 3 again, but this time it's the root 3's that cancel, which gives us root 8, which will simplify to give us root 2 and 2. The next one, we're looking for a factor of 5, so that's going to give us the square root of 40 times the square root of 5 would give us the answer we need. However, what we've got to remember here is there are other factors. It could have been root 10 times root 2, but that wouldn't cancel the root 5 down the bottom. So when you have a choice of more than one, you want to make sure you pick the one which is going to help you to cancel your denominator. So it's better for us to pick root 40 times root 5 here so that the root 5's cancel. That gives us root 40, which we saw from a previous exercise can simplify to give us 2 root 10. Now 39 and 3, we know that 3 13s make 39. In this case we can get the root 3's to cancel, and we're just left with root 13. It's also a prime number, so that can't simplify anymore. Now the next one's got an added problem here. It's got an extra value in front of the numerator surd, which we just ignore for the moment because we're going to cancel the surds not to do with integers. So that gives us 3 times root 7 times root 3. The root 3's cancel once again, and as you see it just gives us the 3 root 7. So the 3 there didn't actually influence the answer in this case. However, in the next one, what we'll have here is we've got 6 root 24 and 3 root 2, so right from the very beginning we could cancel the 6 and the 3. However, if we leave them in just now and we just look at the surds, we know that it's root 12 times root 2 that gives us root 24. We then have that the root 2's cancel, so I've got 6 root 12 over 3, and if we tidy that all up, we end up with 2 lots of 2 root 3, which returns us 4 root 3. And the next one, we've got 4 times root 9 times root 8 divided by 2 times root 8. The root 8's are going to cancel this time. That'll give us 4 root 9 over 2, of which eventually gives us the value 6. 4 divided by 2 is 2, the square root of 9 is 3, 2 times 3 is 6. So hopefully that's given you an idea of the things that you can do with surds, and now you can go try some more for yourself. Thanks for listening.